This example demonstrates how a binary search tree can be created and nodes will be removed. We assume that a set of integers are given and they are supposed to be maintained in the binary search tree fashion. I am sure that users will remember that the binary search tree is the one all the nodes whose values are more than, rather I say all the nodes which are right to the a node will be having values more than this node. Similarly, all the nodes which are left to the node will be having smaller values less than a node. So we have to create a tree, binary search tree, which will have this type of property. In the following slides, we will demonstrate how the same thing is carried out. Assume that initially the search tree is empty. "45" is inserted. "23" is supposed to be inserted. As 23 is less than the root node value, it will come as a left subtree. Now 46 has to be inserted. As its value is more than the root node value, it will come as a right subtree. Now 11 has to be inserted. As 11 is smaller than the root node 45 and also its left child, so that this becomes the left child of the root node's left child. Now 21 is supposed to be inserted. The 21 is less than the root node and also less than root node's left child, that is 23, and it is greater than 11, thus 21 is inserted as the right child of 11. Now 54 has to be inserted. 54 is more than root node value 45. Thus we come to right subtree. 54 is greater than 46. Thus it will be made as a right child of 46. Now let us assume that the user has entered 48. It is more than the root node value 45. It is more than root node's right child 46. However, it is less than 54. Thus 48 is made as left subtree of the 54. Now let us assume that 27 is entered. 27, as it is less than 45, will come to right subtree, and it is more than 23, thus it will be made as the right subtree of 23. Like this, tree insertions can be carried out such a way that the numbers are maintained in a binary search tree fashion. I am sure that you have observed that all those numbers which are more than a given node value will be seen in the right hand side, which are less than a given node value will be in the left hand side. So this property has to be satisfied while creating the tree. Of course, there is a danger that if we go on enter numbers in ascending order numbers, then we get a binary search tree which is a skewed tree. It may be having right skew or left skew also. That we'll discuss in a next session. Let us consider we want to remove 27. Removing a node is not a difficult one here, this node especially. Now let us assume that we want to remove 46. However, if you remove 46, its right subtree, that is 54 and 68, etc., they become dangling. Thus, before removing 46, so we make its right subtree to come into its place, and then we remove 46. Let us assume that we want to find 43, whether it is available in the binary search tree or not. Thus, we traverse from the root node. Compare the root node value with 43. If it is same as, we can return the address of the same. Otherwise, if it is more than, that is root node value is more than 43, then we come left side and traverse the left subtree. Otherwise, we go to right subtree and traverse. This we repeat all the places till we go to the leaf node. We did not find 43. Let's assume that we want to find out whether 90 is there in the binary search tree or not. Ninety is also not found to be available in the binary search tree. Let us assume that we want to find out whether number 77 is there in the binary search tree or not. Now we found 77. Like this, binary search tree is traversed to find out whether a given node is there in the tree or not.